Okay, I am recording, so let's get into our last filter, which is the position one. So here I'm going to show you guys something slightly different than what they did on the paper. If you remember from the paper, the position filter, they also use a quantile approach, like we just did for yield and speed, but they use that on the coordinates. So they use the quantile approach on the X coordinates, on the Y coordinates, and filter based on the quantiles as well. I have tried that at least with some data sets, and what I got out of that was nothing was filtered out. It basically didn't remove any observations. And maybe that was very specific to the data sets that I used for that exercise. But, I stopped for a moment and I thought, why would you use a quantile approach on the X and Y coordinates if you have the boundary of the field, which is something that is pretty common to have, right? I mean, if you're working with precision ag data, you probably have already a boundary of the field, or it's very simple to just create one in QGIS or even Google Maps or Google Earth. It's something very simple to do. So because this data set didn't filter anything out, or maybe it wasn't this, but regardless, because I tried that filter the way that they do in the paper, and it didn't work for a couple fields, I decided to take a step back and offer another option for that position filter. So if you remember, the position filter that they included in the paper, the purpose was to, well, can somebody help me here actually? Can you remember what was the purpose of that position filter? Somebody on Zoom?
To remove the points which are outside the boundary.
Perfect. That's exactly it. So in case there was like GPS drift and the machine recorded a point that was outside the field, or maybe for some reason there was in the same shape file, there was information from two different fields that were not connected and you don't want to analyze them together. That's kind of the reason for that, just to remove points that are outside of the field, and also to remove some of that border effect. So as we saw a couple of times already, I'm just coming up here to show the map. So we definitely want to remove those end rows because of that pattern there. We definitely want to, and I myself think that anything that's near the border, regardless if it is an end row or not, can be erroneous, just because either erroneous from the sense of like the machine got an erroneous measurement, or because just that boundary of the field is not really representative. Like if the field was shifted, would that boundary still yield low or high as it did? Probably not, because then it would have plants on both sides and it would give different yields. And if you've seen field borders, you probably have seen this effect that the border doesn't really represent what's happening in the field. So I think it's a good idea to actually filter out some of those points very near the border of the field from our exercise. So I'm just coming back here to the position one. And so what I'm proposing here is that instead of using the quantile approach to filter position as they did in the paper, that we instead use the field boundary to do that. And one downside of that is, again, you have to have the boundary of the field, which in this case we have. So the boundary is one of the other files I sent you that should be, so if you come here on your files, so project R files tab, and you go into data, I have a few more things that you don't have, but you should have the KB2 yield 2017 CSV, which is what we've been using up until now. And you should also have the KB boundary.geojson. You should have this file there. If you don't, please speak up, because you're going to have it to move forward. Yeah. You don't have? Okay. So if you don't have it, what you're going to have to do is go to my GitHub page. Just move this. So it's github.com/Leo M. Bastos. So if you go there, and then you look for this repository here called 2022 Advanced PA. You're gonna have to download this by clicking code and download zip. And that file is gonna be inside of the data folder when you download it to your computer. So download that to your computer. And when you have it downloaded, what you're gonna have to do is then unzip it. Let me just show you what I would do on my side. And that folder itself doesn't really matter where it is in your computer. You know, if you want to have it in a place that makes sense, you can place it on your course folder. So this is what I have on my side. So that's my GitHub folder. So this is where you would have your GitHub folder as well. You're going to have to go inside data and copy that boundary GeoJSON. And then you get outside of that GitHub folder, go inside the folder of your project. And this is all being done outside our studio, right? This is on your file explorer system. So then you go inside of your personal folder, go on the data folder and paste that kb boundary.geojson if you don't have it yet. While we wait here on the room, everybody on Zoom, does everybody on Zoom have this folder on your data folder? Okay, awesome. Just gonna give a moment here. Yeah. Mm-hmm. And then you want to paste that inside of the data folder of your project. Not there? Let me come to. Yeah, you got it. Yeah, that's right. Perfect. All right, so let's now so we have this file in our data folder, but we want to read that into R so we can actually use it. So here, please go ahead and come to this chunk here where it says importing boundary, add the assignment symbol, and we're going to use a new function here called read_sf. So if you recall, the first time when we imported the yield data set, we used read CSV because that yield was in a CSV format. Now, our boundary file is on a GeoJSON file type, which is a geospatial file type already. And the SF package can read multiple different formats of geospatial data, including GeoJSON. So we're going to use here read_sf. And then you can open and close quotation marks, have your cursor blinking in between the quotation marks. And if you hit tab right now, it may fill completely with that partial name there, or maybe it's going to show you for me how it is shown here. But what I want to show you there is that right now the location that is seen is inside the code folder. You want to get outside of the code folder, go inside the data folder and call the GeoJSON file. So again, to get outside of a folder, you do // If you hit tab after that, you're going to be at the root of the project. And then you navigate to data, hit tab, hit return to accept, hit tab again, and then select that KB boundary.geojson. So this is what your code should look like. And
You know,
can,
before we move forward, would you mind explaining to the students the difference between a shapefile, which most of them are familiar with, and a GeoJSON file, which some of them may have not been are not familiar with?
absolutely. And that was actually my next step here. And that's a really
Oh, okay. Sorry.
no, it's great. You're because that's a really important point here. So probably most people work with shapefiles, right? And shapefile is a proprietary format from ESRI or ESRI, the company that makes ArcGIS. It is an open format, meaning that you can access it in OpenNR if we want it. And multiple other softwares create shapefiles, and we use a lot of shapefiles. Now, the main difference is that if you have worked with shapefiles in the past, you probably know that shapefiles have somewhere between 4 and 7 different files, all attached to the same shapefile. And that sometimes can be a problem because, like, if you have a shapefile and I ask, hey, can you send me your shapefile? You have to send all those complementary files with the shapefile. Otherwise, it will not work for me if you send me. And GeoJSON is another format really for geospatial data. It is not as commonly used, perhaps because ESRI and shapefiles were the leaders in the industry. So they just set the tone of what was the file type used. But GeoJSON is an open format file, meaning that there is no company making profit out of this type of file. And not that Esri is making profit out of shapefiles directly, but it is attached to a company. So GeoJSON is an open format for geospatial data. But that is not what is the most attractive to me, at least. What I like the most about GeoJSON file is, as you guys saw, it's only one file for that shape that we're importing. Whereas if we had a shape file, you would have to download it and copy it about 6 to 7 different files that would all represent that one shape file. This is the main reason why I decided to use GeoJSON. And yeah, so that's the explanation there. All right, so if you're able to import, you know that you would find this on the environment on the right, and if you print it, you should see something like this. So 2 panels being printed again. If we just switch the first one, what we see here is a couple of different things. So geometry type now is multi-polygon. If you recall our yield, I'm just going to print here so you can see. You don't have to do this, but I just want to give you that comparison. Our EO17W, which is geospatial because we did all that, it is a geometry type point. Now, our boundary is geometry type multi-polygon because it is a different type. Normally, and I guess you can say, yeah, almost always, shapefiles, or in this case, a vector file, more generally speaking, is going to have only one type of feature. In this case, the feature here is a polygon. On the yield, it was point. And just to quickly show you here, this is just part of one of the chapters of that geocomputation in our book that I share with you. That is free. You can access this. But these are just some of the different types of shapes you can have in a vector file. So it could be points like our yield data. It could be a line string, and it could be a polygon. So these are the most common ones. And Sarah, just to point out to you here, something that probably I'd never really seen the type of data that you work with in animal science, but I imagine that it would probably be taking points for an animal as they move. Is that correct?
It depends on the situation, but when I've done research with horses before, we've put little balls like on their joints, and it's taken data like that, like as the joints move.
I see. But then like it would be taking a GPS coordinate at a given distance that they move. Is that kind of what it does?
I think so.
Yeah. So in your case, whenever you work with this data, I would imagine it would be a point data as you bring in to any software. But because it is like a point being created by an animal moving around, you could at some point transform all that point data into a line string where you connect all the points for a given animal and you see the path that they moved around. So I guess that's something just to point out. Okay, so coming back here to our studio window, another thing that we see here is that if you remember when we brought in the CSV, it was not a geospatial data, so R did not know anything about it, didn't know that it had X and Y and that it was reported on WGS 84. In the case of a GeoJSON file, and a shapefile would be similarly too, it knows it's geospatial already, and already even knows what is that geodetic CRS. It is WGS 84. So this is not something that we set up here. It's already coming with the file, that information, which is always great if that can be with the file already. Okay, so what I want to ask you to do next is to just come here to the chunk below. We're going to do a very, very quick wrangling here. There's not really much to do because this data set only has one row because we only have one polygon in this vector file. So if we come to boundary W, we're going to start off with our boundary object. And because now we know how to use pipes, we're going to use that here as well. So you include the pipe, hit enter, and we're going to use the function st_transform, which we have already used on the yield data when we transform from WGS to UTM. I also want to do that here. And here is, at least at this point in time, is even more important that we transform. Because if you recall, WGS 84 is in degrees. And we're going to create a buffer based on this boundary, which takes into account distances. And I want that to be in meters to be more realistic. So we're going to transform this from WGS to UTM. So to do that, we just specify the CRS here, and we're going to use the EPSG code for UTM 16 North, which is 6345. It's the same code as we used for yield when we did this step. So if you just run this and you print and you again come to that first panel, you're going to see now that it is saying projected CRS in 8083 UTM zone 16 North. That's what we wanted this to be. So now both the yield and the boundary are on the same projected CRS. Okay, so I want to invite you to come to the next chunk here. We're just going to do a plot. So let me see here. So what I want to do is just start a ggplot like we always do. Add a plus, hit enter, and then we're going to do geom_sf and just say boundary_w. Oops, actually we have to say, sorry, data equals boundary_w. Okay, so that is our boundary. Maybe it's not as clear to see, but it has a gray background, which if we wanted to show the yield data behind it, it wouldn't appear. So we can just add here a comma and say fill equals NA to remove that gray fill on the background. So now we see what's behind it. And again, this plot here does not have the yield data in it because we didn't ask to add that layer, but now we can see that the boundary, we can see through the boundary. Okay, so this is basically the polygon that we're going to use to filter things afterwards. Okay, so if you can come here to the next chunk here, let me tell you what I'm planning. So my plan is, so right now we have the boundary of the field. You know what? Let me just do something else here, just so you can actually see what I mean by some other things. Come here after this plus, add again geom underscore SF. And say data equals, so is that yield 17 underscore W underscore SF. That SF was the speed filtered, so was the last filter we did. If you just do that and add a plus and run it, we're going to be able to see the yield data, sort of, because it's kind of hard, but let me just come to the boundary one and say color equals red. So that's going to change the outline to red, but remain the fill as NA. So we can kind of see now that perhaps some points already lie outside of the boundary. But the thing is, we have all of those points really close to the boundary where we were seeing lower yields in the previous map. And the goal is to remove those points really close to the boundary, but inside the boundary, not outside of it. In this case, we don't have any points outside the boundary anyways. So like there are no points up here or anywhere there, but we want to create a buffer from which we're going to exclude points. So to do that, let's come to the next chunk here. Use that assign function. We're going to start off with our boundary underscore W object, add a pipe, hit enter. And then the SF package has a function called st underscore boundary. And it has an argument for the distance that we want to create a buffer. It's, oops, sorry, it's not boundary, my bad. It's st buffer. Yeah, so st buffer is the function, and it has an argument for dist, which is the distance from that boundary that we want to create a buffer. If you put a positive number, let's say 20, it will create this buffer going outwards, so expanding outside of the boundary. However, in our case, we don't want to go outside the boundary, we want to go inside the boundary and remove points that are between, let's say 20 meters in and the boundary. So we do a negative 20 here. So if you can do that, please, and run it. So this is basically creating a buffer that is 20 meters in size, going inwards that boundary. And if we just print it, it doesn't look any different. But if we plot it, let me see here. I don't think we actually created this object here. So let me just, yeah, I left you some code that I think at some point I changed and I forgot to update. So this yield map raw doesn't exist. Let's just, perhaps let's create that, and then that's going to be helpful. Yeah, let's create this object yield map raw. So what I meant by that was basically if you, so this was improvising a little, or me actually improvising a little bit. If you can just come here on top and you can go to that green button there, which is to add a chunk. So click on it and select R, is going to add a chunk. So we can just name the chunk yield map raw. And then what we're going to do is create an object that is called yield map raw. Use the assign symbol there. And we're going to have a map that we're going to create that we're going to be reusing this map for other reasons. So let's just start that map. So that map is ggplot. We add a plus, hit enter. We add a geom underscore SF, where data equals the yield filter data. So yield, or actually in this case is the raw data. So it's yield 17 underscore W. And then we say AES for aesthetics. We say color equals yield pound per acre. After that, we add a plus, hit enter, and we say scale underscore color underscore viridies. And if we print it, we should see that map that we have already created above, but it was just not not saved. So now, just walking you through, we made a ggplot with the raw yield data and we saved it to an object. So now every time we print this object is actually going to print that plot for us. And the cool thing about it is that we can just recycle and reuse this starting map and just add layers to it as we do with ggplots. And that's what we're going to do next. So if you were able. Okay, so that if you were not able to use the scale color varieties, this is coming from the package. So to load that package would be library varieties. If you run that and it tells you don't have this package, please let me know, and then we can just do a quick install.packages.
I think I need to do the install package.
Okay, so yeah, if anyone else also needs to install, you would just do install.packages, open and close quotation marks, and just type varieties. And you can just run that. Remember that after you install, you can just delete that install.packages because we're not going to be installing it all the time, but you're still going to need to load the library varieties to use it. And if you just click play here, it's not going to work. What's that?
Can I use this for the class analysis?
I mean, if you don't
I'm
make
not
any
going to talk
sound, then
anything.
yes.
I'm not going to talk anything. just
Yeah, absolutely.
quietly work.
Yeah, sounds great. Yeah.
Thank you.
Yeah, no worries.
Object varieties was not found when I tried to do the install packages.
Did you have varieties between quotation marks? Yeah, it's kind of tricky that on the install packages, you have to use quotation marks, but on the library, you don't. So it's kind of confusing, but yeah, and once you install, if you just play this chunk here, it's probably not going to work the first time just because library, at least on my code, library is after using the function. So you have to just move that up like that. Anyone else having issues, need help?
Having issues, but it's probably I am missing something in the code. I'm trying to troubleshoot.
Here, when making the yield map raw?
Yeah, somewhere I have an error. It's a typo somewhere I'm trying to find.
I'm kind of in the same boat as Dr. Velitas. I've been following along, but trying to troubleshoot. So I know that this is kind of backtracking a little bit, but whenever at the very beginning, when we have boundary and we put in the .. /data KB boundary, mine is telling me that the file doesn't seem to exist, but I see it right here on my little, where it shows the files, plots, packages, that portion of the screen. I see it. So it does exist. I just don't know why it's not pulling it.
So do you want to share your screen?
Yes.
Let me stop sharing. Is that?
Sorry to make you backtrack, but I was just trying to see if I could figure it out myself, and I cannot.
No, I mean, we have to have that. So I'm glad that you spoke up. Okay, so I see you have your project there and here. Oh, okay. So what happens is, is this the GitHub one or is this your own project?
This is my own project.
Okay, because like on the path there, so on the right, so on the files tab, I see the path. I see it's
Oh, yeah, I see. Yeah.
Yeah, it looks like it's still on the GitHub one. In which case, you just have to like go in your file explorer and just copy
Okay.
that KB boundary GeoJSON from that 03 data into your actual project data folder.
Okay. Where's the? Yeah, that one.
Yeah, so just copy from there.
Okay.
Well, but I don't think that's it either, right?
Okay.
Because like you want to go into the main folder of your project, and I don't think, well, because like the main folder of your project should have like the data, code, and output folders, remember?
Right, right.
So I don't see those in
Okay.
there, but maybe it's just the way you have it. So if you just want to go inside that folder, the EKB folder,
Uh-huh.
and just create a folder there, and just call it data, and then just move that GeoJSON into that folder.
Okay. Okay.
Yeah, and now it should work. Let's see.
Okay.
If you go back to,
All right. I need to.
if you just play that chunk. Oh,
Oh, okay. Well, that's fine. Yeah.
let's see.
Let's see.
I don't know now. Yeah. Okay, it did work. Yeah.
Yeah, it ran. Okay. Thank you so much. I'm sorry about that.
Yeah, no worries. Is it working, Victoria? Okay, perfect. It's been all good. All right. Anyone else having issues? All right, so I'm going to share my screen here again, and then we'll continue. Okay, so and Emily, just to let you know, then so make sure that you run this piece of the code here. Also, this piece here. Did you have that typed already?
No, sir. I missed that. Let me.
Okay.
I got it. I
yeah.
got it. You can go ahead and scroll down. I took a picture of it.
Well, no, I mean, we're going to need this, so please go ahead and
Okay.
type. Yeah,
Okay.
you can take a moment. Yeah, just please let me know when you finish this part.
Got it.
Perfect. And then, I mean, the next one we did a plot. If you don't have it, that's okay, because,
I do. Or it just didn't do the boundary, but
okay, perfect.
thank you.
Awesome. And then were you able to get the buffer part?
Yes, sir. It just wouldn't run because I didn't have the boundary, but I got the code for it.
And if you run, does that work all right?
Let's see.
Yeah, so this one here relies on the boundary W, so you would have
Right.
to run, you would have to have this part here run,
Mhm.
the boundary W one, and then the buffer.
Okay. 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 Try this. Can you scroll back up to the to your boundary plot? Yeah, right there. Let me
So
see.
this one here is not using or saving to any object, so this should not cause you any issues
Okay.
in the code below. So the
My-
code below, oh, go ahead.
Oh, I was just gonna say the boundary is just not popping up.
So it kind of starts here. So for the buffer to work, you have to have the boundary imported, which I think you did. And then you have to have this here, which would just transform that to UTM.
Mhm.
And then that should be all you need to get the buffer going.
My code matches yours. I don't know. We can look at it later if you'd like. I don't want to hold everybody up.
I mean, it should be a quick fix, I think. If
Okay.
you want to share your screen, we
Sure.
can try to troubleshoot it. If
Sure.
it's more complicated, then we can work on that later.
Okay.
Okay, so you did, it would be, so you did import the boundary. So when you
Mhm.
run that chunk, so the chunk here called boundary W on line 329, if you run that, does that go through? Like if you just run that chunk,
Yes, sir.
that goes through, and then you can just skip the plots. We don't have to worry about it.
Okay.
And then the buffer, if you run that, Yeah, you got it.
Okay, I was just worried because my red boundary didn't pop up. My bad.
Oh, yeah. Oh, no, no worries. Yeah, I guess, but yeah, if you just go back quickly there, I think you're missing a plus after the.
Oh, okay. Yeah,
Yeah.
you're right.
that's
Easy fix.
the
Thank
trick.
you.
Yeah, no worries.
Appreciate it.
All right,
Okay.
so I'm gonna start sharing my screen again. So we stopped here. So if you, oh, George, were you able to get this part going?
Yeah, I found like 10 typos in my code. You were moving a little fast for my typing skills there for a moment.
Oh, yeah, and I'm sorry, and if anyone else has, if I'm going too fast, please let me know. I try to narrate things as I'm going, but I know that I write fast and I know what's coming up, so yeah, it's easy to just get in the moment. Okay, so if you were all able to just create this object, you can just come here to the next chunk and you just run it. It should work now that we have all that. The only thing is we're gonna have to give it a color. So let's say color equals green, so we can see it. Yeah, so in our, and also, okay, so after we do this, that you just did there, let's also add the buffer, because the boundary. By doing geom sf data. You know what? I'm sorry, I'm getting you confused with my confusion. We have just added the boundary, but my goal here was actually to show you the buffer as well. So just add a plus there. So what we're seeing here in green is the boundary itself. Now I want to show you the buffer. So data equals buffer. That's the object we created. We can say also fill equals NA, and color we can say red. I know it's not a gray selection here, but it's just going to be bright in our eyes to see the difference. So if you run that, now we're showing in green the boundary itself. Oh, did I miss a fill? Oh yeah, I mistyped fill. Filla, that's not what I wanted. So fill NA, let me go back to the code so you can see. So the green outline is the boundary that we imported, and the red outline is the negative buffer that we created. So now the goal here that we're gonna filter on this position filter is to actually remove all data points that are in between the red and the green outline. So basically removing anything that is within 20 meters from the field boundary. Now, one thing I want to point out is 20 meters was pretty arbitrary. That was in the paper, because they don't use this approach. I could not get anything from there as far as a reference. 20 meters I thought was a good number, but depending on the field size, perhaps on the field shape, that number could differ, just so you know, because again, my goal here is that if you guys have to clean yield data anytime in your career, hopefully this script here can be a way that you can do that, or at least help you give some idea of how to do things. So I just want to make that disclaimer that the 20 meters was arbitrary. And you don't have to do what I'm gonna do next, but let's say if I thought 20 meters was not enough and I wanted 40 meters, you just go there, just increase that negative number or decrease that negative number from 20 to 40. And then if you plot it, we're just going to see that it goes more inwards as compared to 20. So I don't want you to use 40 now because, the main idea was to use 20 initially. And again, nothing special about that, but I want all of us to get the same results. So we have to have the same buffer size. So just going to return here and do 20.
In what unit is this?
This is in meters. And again, this isn't, I know it's in meters because we transformed that from WGS, which was degrees, to UTM zone 16 north. And we used because you can get UTM data that is not meters. It could be in feet, depending on the on which one you select. But the EPSG that I selected was in meters. I mean, it gives you the result in meters. So that's how I know, or that's how we can know what is it. Okay. So this is, again, just visually for you to see what we're going to do, what we will filter out. And then we're actually going to apply the filter right here on the next chunk. So on the left here there, the name of the object I want to give it. So yield 17 WPF for position filter. So we use the assigned value there. And we're going to start off again with the last filter we applied, or with that data set, which was the speed one. If you recall, the speed data set, the filter data set from the speed was yield 17 underscore W underscore SF for speed filter. Then we use the pipe, we hit enter. And then we're gonna, here is gonna be a little bit different. We're gonna use a function because now our filter is based on geospatial data. It's gonna be based on whatever is within the boundary or whatever is outside the boundary pretty much. So to do that, we're gonna use a function called st underscore intersection. There is an intersection and there is an st intersects. Be sure you're selecting st intersection. And then we're just going to say buffer. So what it's going to do is going to pretty much match the yield layer, the buffer layer, and only keep whatever matches both of them, whatever overlays both of those layers. So that's what happens here. So if you run that and you're successful doing that and you print the data set here, you see that now we have like 27,000, almost 28,000 rows in this data set. And on the previous one coming from the speed had like 28. So it removed about 1,000 again. So for each one of the filters we applied, we removed different 1,000 observations from this data set compared to the raw one. Okay, so if we just come here on the next chunk, what I did is, what I've been doing up until now with the summary function was to show you how speed changed or how yield changed, but now it doesn't really make too much sense to show you how meters changed. So my idea here is to show you a summary of the yield after being filtered based on position. If we run that, we see that the minimum is still the same as before, I believe. I think the maximum may have changed. Let's see. So 5674. If you want to stay on this window here, actually, let me pop that out so I can have here and I can compare to, I think it was here. Well, I'm just going to go back to where I was. And I will just do another trick, another improvisation here, just called summary of the yield 17. You don't have to do if you don't want to. I'm just doing so you can see on the speed one, which was before we applied the position filter, how that changed. Okay, so minimum remained the same. Maximum changed, maximum decreased a little bit after applying the position filter on the data that had already received yield and speed filters. The mean changed a little bit and the median as well. So it seems like it was not trimming the ends as much, the ends of the distribution as much, which makes sense, right? Because we're not using a quantile approach, but perhaps it was trimming some observations that had yield values that were considered okay, but that they were on that near the boundary of the field, and we know that that could have issues most likely. Okay, so still got a few things here that I wanted to show you. Maybe we can try. I mean, we have 4 more minutes, so we can try that. So what my next step here is to create these summary statistics, both numerical and graphical, comparing the completely raw data as far as like the U17W. So before we applied any filters, and the clean version, which is after we applied min and max yield, min and max velocity, and position filters, and see how that works. So to do that, I left you already there the starting date. So for the raw data summary, we know it's the U17W. We're going to use the function called summarize. So I want to invite you to go to that function, have your cursor there, and we're going to add a few different things here. So the first thing I want to know is how many rows are there in this data set. I want to call that column N for just like number of observations. So here N is the name of the column that I will get after applying the summary function. And what I say after the equal sign is what's going to be done and saved on N. So that if I want to know how long a data set is as far as rows, there is a function called length. So we can say length, and then inside here, we have to give a variable name from this original data set, which I'm going to use yield underscore pound per acre. If we just run that as it is, the output is just a data set with a column called N and with the number of rows that that original data set had. However, that's not enough for me. I want to know minimum, median, mean, maximum, standard deviation, and coefficient of variation. So we can really compare those basic statistics between raw and clean. To do that, you can come here after this parentheses, add a comma, hit enter to break line. The next thing I want to create here is a column called min for minimum. And on this column, I want to have the function that is pretty intuitive. It's called min as well. And then inside of the function, I also need to give yield for what column I want the minimum of to be extracted. After that, you add a comma, hit enter. Next thing I want to extract is the mean. So I want to call this column mean. And again, the function is pretty self-explanatory. It's called mean. So I want the mean of yield like that. Add a comma, hit enter. I want to do the same here for maximum. So the column is going to be called max equals. We use the max function and extract from the maximum value of the yield column. Add a comma, hit tab. We only have a couple more here. So the next one is going to be the standard deviation of yield. I'm going to call this column SD, say equal. The function, again, pretty intuitive, is called SD. So SD of yield. And lastly here, add a comma, hit tab. I want to calculate the coefficient of variation, which I want to call this column as CV equals. There is not a direct function for coefficient of variation in R, so we're going to have to do that ourselves. So right after the equal, you can open and close parentheses. Inside of the parentheses, to calculate coefficient of variation, the formula is SD divided by mean. And here, because we have already created above the SD column and the mean column, it knows to use those two columns to calculate the CV. And then we just say times 100 outside of the parentheses. So this is all you should need. If you got all of your parentheses right and all of your commas right, and you run it, you should get these columns below here. So 21,000 rows approximately, minimum 0, mean max, standard deviation of 1,033, and a coefficient of variation of almost 36%. Okay, were you guys able to get to this point? On Zoom, everybody able to get here? Okay, I just want to show you last thing before we finish today is the raw filtered. So I left already all that code for you. You can just run it. And I just want you to take a look and compare all of these statistics for the raw, which is above here. And actually here is not raw filtered. It should be, the chunk should be called filter summary. I named it not intuitively. So if you compare the summary of the raw and the summary of the filtered, like how many observations did we remove? How did mean, minimum, mean, maximum change SD and coefficient of variation? One thing to note is how standard deviation and coefficient of variation decreased a lot on the filter version compared to the raw. So the CV went from 36 to 27, just so you have some idea. And then the last thing here was I had some plots that I wanted to show you. I think I'm gonna have to skip that just because we're running out of time. But I want to tell you this before we go. I will have an assignment that I'll give it to you today. I will send you by email. I would just want to quickly explain what we're going to do. And then the only thing here, and I apologize for the short notice, but there's really no other way because of the way the class is structured. I will send you 2 other raw yield data sets, and you will have to wrangle the data sets, do the minimum, maximum yield, velocity, and the position filters. It is the same field, so you can just reuse the same boundary you have here, but you're gonna have to apply all those layers. And at the end, I want you to export that filter version to file. We haven't done that here today. I will send you the complete version of this script today so you can see how I do that. It's not difficult, it's super simple. If you have issues, always please feel free to reach me out. I can help you, certainly. But the caveat here is that you're gonna have to go through and clean 2 yield data sets by tomorrow midnight, tomorrow 11:59 p.m. It should not be difficult. You should just be able to copy and paste this same script on your code folder. Just copy and paste it. Just rename it, give it a different name based on the yield data you'll be cleaning, and just change that data coming in. You're gonna have to adapt the name of the columns yield and speed because they're named differently in these data sets. I wanted to leave that as a feature and not a bug, because I think it's important for you to know that you're gonna have different data sets coming in. You're gonna have to adapt your code to them. And it should not be difficult for you to just adapt those names and rerun everything as is. So you're not gonna have to code much, very little. Just adapt to the code that you already developed and just do this and export the clean versions, because on Friday, we're gonna have to have the 3 yield data sets cleaned, which is the one that we just finished today, and then the 2 that you're gonna get from the assignment. And we're gonna use them on Friday when we're gonna do interpolation. Okay? So again, I will send you all this information by email. It's gonna be very, very well explained. And the only caveat is you're only gonna have a day and a half sort of to get this done. But it should not take you long. You're not gonna be coding too much, just adapting the code that we developed today, that we finished developing today. All right? So with that, anyone has any questions on Zoom? Okay, so if you have any issues going through the assignment, please let me know. I want to help you, and you will have to have these to continue on Friday. So if you get stuck, reach out to me. I will help you out for sure. And we're gonna get through this. But otherwise, thanks for joining today. I hope you guys enjoyed going through all these different filters, and see you Friday.